welcome back with another tutorial of this fun physics problem, and I'm just gonna explain to you this problem step by step. Whoever is willing to increase their knowledge of in this specific chapter. Okay, so I'm just gonna give you the information that in this problem is that the intensity of the sunlight reaching the earth is 1360 watt per meter square, and assuming that the sunlight is absorbed. So you have to make sure whatever you're reading, and you can do your research, and you will know that there's two things when if it has to do with the sunlight, if it's absorbed or reflected, it's the same formula, but it's a different way to write it down, especially when it has to do with a radiation pressure force that a light coming from a star to a planet. So I will go step by step in this problem. They want the force in Newton. I'll go from the basic. We know that the force is equal mass multiplied by acceleration, okay? Everybody knows this. And we know that force that exists in between two objects has to do with gravitation, mass of the first and mass of the second multiplied by the distance between them. Now, we know that this is where your physics knowledge has to come into work. And if you don't know, that's okay. You can still look for it, because they will not tell you in this chapter. Every chapter is connected with another chapter. You just have to remember, because sometimes you will forget. So what they did here, first step, they took the pressure formula of an energy flux divided by the speed of light, and that's the pressure that the sun exerts on the earth. Somehow that pressure, the energy flux, is the intensity that's that the sun exerts on earth divided by the speed of light. You can search for the relation between energy flux and the intensity, but they have a relative points between them. So because they have the same how to call this the same unit. That's what I was going to say, the same unit. But anyways, the pressure is equal to 1360 watt per meter square divided by the speed of light. Okay, so that pressure is equal to 45.33 multiplied by 10 minus 7 pascals. The first step is to find the pressure. Then they took the force formula related to the pressure, and that's pressure multiplied by the area of earth. Okay, so the force is equal to 45.33 multiplied by 10 power 7 pascals multiplied by pi, and the radius of Earth is 6.4 multiplied by 10, 6 meter square. So the force will give us 5.8 multiplied by 10, 8 in Newton. That's the force that the sun is exerting on Earth. Okay, and if they want the fraction of forces between the sun gravitation force on Earth, we can use that force is equal to gravitation multiplied by the mass of the sun, mass of Earth, divided by the distance square. The distance between Earth and sun. So the gravitation is a constant that is equal 6.67 times 10 minus 11 Newton meter square divided by kilogram square, and we're going to use it in this formula. The mass of the sun is 2 multiplied by 10 power of 30 multiplied, this is in kilogram. The mass of Earth is 6 multiplied by 10, 24 kilogram, divided by distance between them, that's 1.5 multiplied by 10, 11 meter square. So that force is equal to 3.55 multiplied by 10 power of 22 Newton. And if you do the fraction of forces, it's gonna be 5.85 power of 8 Newton divided by 355 multiplied by 10, 22 Newton. And that's equal to 1.64 multiplied by 10 minus 14 Newton.